Hi, in this question it is said that a 10-meter long potentiometer wire carries a steady current. A standard cell of EMF, so the EMF is given 1.018 volt, right? So the EMF is balanced against a length of 254.5 centimeter of the wire. So the balanced length L is equal to 254.5 centimeter, where the total length of the potentiometer is 10 meter, right? So now the question is, what is the potential gradient across the potentiometer wire? So the potential gradient is written as K. So we have to find out the potential gradient of this potentiometer wire. Now, what is this potential gradient? So potential gradient can be defined as the decrease in potential, per unit length, right? Where the decrease in potential is V and per unit length will be L, where L is the balancing length and V is the potential difference between any 2 points. Potential difference between any 2 points. Okay. So it is said that in this potentiometer, the balancing length is 254.5 centimeter, okay, against this EMF 1.018 volt. Okay, it means that at this length 254.5 centimeter in potentiometer wire, the galvanometer will show no deflection. That means no current will pass through the junction. So at this length, the galvanometer, that means the null point will be at 254.5 centimeter from the high potential point. Okay, so at null point, null point means the point where the galvanometer will show no deflection, that is no current will pass. So the galvanometer shows no deflection. Okay, and that particular point is known as null point, and the distance from the left hand or the from high potential point will be 254.5 centimeter in the potentiometer wire. Okay, so now V is the potential difference between any 2 points, and it is said that the EMF is 1.018 volt. That means the potential difference will be 1.018 volt. Okay, and against the length is given. So what will be the potential gradient? C. So K is equal to V by L, as we know, where V is given 1.018 and the balancing length is given 254.5 centimeter. Okay, the unit will be volt per centimeter and the answer will be 4 into 10 to the power minus 3, or we can also write it as 0.004 volt per centimeter. Okay, so this is the potential gradient of this potentiometer, and we have to remind that the definition of K is the decrease in potential per unit length. That means if the length increases, that means if the balancing length increase, the potential gradient will be less. Why? Because we can see that K is inversely proportional to the balancing length. So as we increase the balancing length, it will decrease. Okay. So this is the answer of this question. So I hope you understand the concept and the solution. Thank you. All the best.